Here in problem number 3, we're asked to find the least common denominator of these two fractions. Now, the least common denominator is the smallest quantity that both of these denominators will divide into. Now, you can see this one just by knowing some arithmetic here, that the LCD is 9, right? 9 is the smallest number both 3 divides into and that 9 divides into. But there is a method for doing this. What we're going to do is we're going to factor each one of these denominators into its primes. So 3 is already factored into its primes. And then the 9 we can write as 3 times 3, or 3 squared. And then what we do is we choose each factor, we write down each factor that appears, 3, and then we use, if it appears more than once, as this one does, it appears here and here, we use the factor with a higher exponent, which is the 2 in this case. So we'll get 3 squared, which is 9. We'll use the same idea here in number 11. These denominators are already factored, so we'll write the factor that appears and write it to the highest power. So we're going to have a y. Now the highest power we've got here, we've got a 4 and a 9. The 9's higher, so we're going to write this as y to the 9th. That's our LCD. And sure enough, y to the 9th is the smallest quantity that y to the 4th divides into and y to the 9th divides into. And we'll use the same idea here in number 21. Look at these denominators. Now the smallest number both 3 and 7 will divide into is 21. And we know that 3 and 7 are already written as primes, so we'll just multiply them together. 3 times 7, that'll give us the 21. And then the z appears, but it appears twice, but just to the first power. So we're going to use z to the first. So there's our LCD here. In number 15, with these two denominators, you can see, can you see what the smallest number that both 10 and 4 will divide into? I mean, it'll divide into 40, but that's not the smallest. The smallest is going to be 20. So I'm going to say that our LCD here is 20 x to the, can you see it? This exponent is 2, this one's 6. So we take the one with a higher exponent, which in this case is the 6. So both of these denominators will divide into 20 x to the 6th. Now these denominators, the smallest number both the 5 and the 125 go into is 125, right? 5 will go into 125, 25 times. So we will get 25, and then we'll get an x. Now, the highest exponent on the x, here's a 5, here's a 1. So the highest exponent is the 5. And then with the y's, here's the exponent of 1, here's one of 4. So we'll take that highest one, we'll take 4. So there's our LCD, 25x to the 5th, y to the 4th. In problem 23, we've got these denominators, x plus 8, x minus 8. Now, these are terms. This is going to be one term here, another term here. This is not x times 8. So I'm not going to have an individual x, and I'm not going to have an individual 8. I'm going to take this as one quantity. So we're going to have an x plus 8, an x minus 8. These are already factored, so we just indicate that factored form. So I'm going to indicate the LCD as the x plus 8 times the x minus 8, and we're not going to multiply them out. LCDs are better left in factored form. So in number 29, to get the LCD of these two fractions, let's factor these denominators. So let's do that now. We'll get 3 over, let's take a 5 out, we're left with x plus 1. And in the second fraction, we got negative 1 over 3 times, take the 3 out, x plus 1. And now what we can see is that our LCD is going to be smallest number that 5 and 3 both divide into. That's a 15. And then we've got this x plus 1 and an x plus 1. It appears twice, but it's just to the first power. So we're going to have 15x plus 1. There's our LCD.